Number 89. Among all of the pairs of numbers whose difference is 12, find the pair with the smallest product. What is the product? Okay, so we're going to let x and y be those two numbers. So let x and y be two numbers whose difference is 12. Okay, so without loss of generality, and this is a phrase often used by mathematicians, and it's abbreviated WLOG. Without loss of generality, let x be greater than y. Now, does that make sense, first of all? Well, you have two numbers and their difference is 12, so they're not equal to each other. Their difference is more than 0. Alright, so one of them has to be bigger than the other. Which one is bigger? Well, without loss of generality, let's pick x to be bigger. Okay, so we don't want to lose generality here. We want it to apply to every possible situation. All right, that's the general part. So without loss of generality, we'll just let x be greater than y. Well, what if it's not? Oh, then pick y be greater than x. But you know, it doesn't matter which one. They're just names that you've given to these two numbers, right? Just variable names, all right? So there's nothing wrong with saying that. Okay, so if x is bigger than y, then that means x minus y equals 12. That's because their difference is 12, and x is bigger. So x minus y equals 12. Now, solve that for x. Why not solve it for y? Well, you could, but I don't know. I want to go in alphabetical order, so let's just solve for x. X equals y plus 12. Just add y to both sides. Okay. Now, we're interested in the product, okay? So, we're interested in x times y. xy. Okay. What is xy? Well, x is y plus 12, so that's y plus 12 times y. Now, is this starting to look familiar to you? Yeah, this is kind of like problems we've just been working on. Okay, and you're getting a quadratic function here, right? Y squared plus 12y. That makes sense because this is the quadratic section. All right. Now, I'm not going to complete the square on this. Just to be different, I think I'll do it using the formula. The vertex for this is negative b over 2a. Oops. Let me rewrite this. And you might be wondering why. What did he do wrong? I'll show you in a second here. I'll put parentheses. Now it's correct. Alright. If you write it horizontally, or this is kind of semi-horizontally, negative b over 2a, like this, that could be construed, or if you do it horizontally like this, especially like this, this is actually negative b over 2 times a. All right. I didn't put the a in the denominator. All right. So what you have to do is put parentheses around the whole denominator to make sure that's not mistaken. All right. So the 2a belongs in the denominator, the whole 2a. Okay. So if you write it horizontally, be sure to put parentheses around that whole thing. Otherwise, it can justifiably be marked incorrect by your professor. Justifiably, for sure. Alright, so negative b over 2a, and let's call this quadratic function xy. You know, in the ones dealing with area of corrals, we call it a. So we'll just call it xy. That might look strange, but oh well. You can name these things pretty much whatever you want. And there's our parentheses. A lot of parentheses on this one. So there's your vertex. So that's what I'm trying to get, the vertex. So this is just following the formula. What's A is 1, B is 12, and C, which we don't really need here, would be 0. Alright, so negative 12 over 2 times 1, and xy of that. Alright, so this happens to be negative 6 and xy of negative 6. Thinking of, again, xy is this function, alright? And this is negative 6. What's xy of negative 6? Just plug in y equals negative 6 here and here. So that's negative 6 squared plus 12 times negative 6. So that's negative 6 and negative 36. Now the variables are usually labeled x and y. I mean the coordinates are usually, or we're used to them being x, y. In this case, instead of x we have y, and instead of y we have xy. Alright, so this is y, and this is the product, xy. Alright? So the parabola, how does it open? Parabola opens, let me put an arrow here, opens upward. Okay? So this would, the vertex would be at the minimum point. Alright? So it's asking for the smallest product, and what is the product? So that makes sense. Alright? So this is a minimum point, okay, in our product function. And the parabola opens upward. So again, that's a minimum. So therefore, y equals negative 6. And x, then, what's x? It's y plus 12. Negative 6 and negative 6 plus 12. So that's 6. Negative 6 plus 12. Alright? And the product is negative 36. Okay, there you go. Number 91, we're almost there. But don't forget, after 93, we have two bonus features. So 91 says a rocket is launched in the air. Its height in meters above sea level as a function of time in seconds is given by h of t equals negative 4.9 t squared plus 229 t plus 234. Find the maximum height the rocket attains. So we have a quadratic function of time, gives you height, and we know it opens downward because of that leading coefficient, which is negative 4.9. It's negative, so the parabola opens downward, so the vertex will give you a maximum. Alright, so that'll give us the maximum height. Okay, so again I will use the formula, which seems to be easier than completing the square on this one. So v of negative b over 2a, v is the vertex, by the way, negative b over 2a, and this function is h of negative b over 2a. And since I'm writing these fractions vertically, there's no need to put parentheses around the whole denominator, because you can see that the a is also under the fraction bar there. So you can't see that when it's written horizontally. All right, like I mentioned in the last problem we did. So this is, let me put v colon. Okay, so this is v, all right? And that's, I don't want too much stuff cluttering up the work here. So this is going to be negative 229 over 2 times negative 4.9, and then h of that. H of negative 229 over 2 times negative 4.9. Okay, well, let me, instead of equals, I did this on my calculator, as I'm sure most people will, and I need to round that off because it's a little bit too long to write. So I'll put approximately equal to, the way the equal signs, approximately equal to 23.37, and this is a function of t, so this coordinate, the first coordinate, is t, the time, and h represents the dependent variable, so that's when you plug this number into the function h of t, you get 2909.56 rounded off to 2 decimal places. And this is, again, this is h, the height. Okay, so the question said, what's the maximum height? Well, that would be this right here. The maximum height is 2,909.56, and that is in, what was that again? Height in meters. Height in meters above sea level. All right. All right, we are at the last problem. Finally. All right, this has been one long homework section, right? Okay. And this is saying a mouthful, it looks like. Let's go. A soccer stadium holds 62,000 spectators. With a ticket price of $11, the average attendance has been 26,000. When the price dropped to $9, the average attendance rose to 31,000. Assuming that attendance is linearly related to ticket price, what ticket price would maximize revenue? Okay, linearly related. Remember what a relation is? A set of ordered pairs, right? So these variables are coordinates in a set of ordered pairs, okay, that fit on a straight line. So we'll be using some of the formulas that we used for working with lines in the past, okay. So they're linearly related. In other words, these are ordered pairs that fit on a straight line, okay. So first of all, we need to assign variables. Okay, what do we have here? Let S lowercase equal number of spectators. And what's related to that? P, ticket price. So again, when the price drops, the attendance goes up. When the price goes up, the attendance goes down, right? So those two variables are related. They lie on a straight line. All right. Now, we're going to let R also equal the revenue. Capital R, call it. In other words, the amount of money they're taking in. So we have three variables here. Then R will relate the two variables here, S and P, because R equals what? PS, where this may not be necessary, this little bit that I'm writing, but when you're doing word problems, it's a good idea to write down everything you know. Something might be useful, and other things may not be useful. But it's better to have more than you need than not enough. So this may not have anything to do with solving the problem. What is it saying? The number of spectators has to be between 0 and 62,000. Where do I get 62,000? Because the soccer stadium holds 62,000 spectators. That's what they told us. Okay. So do you understand this? R is equal to, the revenue is equal to the ticket price times the number of spectators. All right, that makes sense, right? Okay. Attendance is linearly related to price, we were told. Let me write that down. Attendance is linearly. Oh, by the way, before I go on, it's important to assign the variables, and even if you get to this point here, you've got half the battle won, all right? If you start getting confused after this point, just kind of back off from it, look at what you already have, and think it over, okay? Don't try to solve this like in a split second. So just take your time with it, play with it, think about it. Okay, so attendance is linearly related to price. That's what they told us. And we have 2 points on the line. They gave it to us. They gave them to us, rather. We have 2 points. And I'm going to call them PS. PS for price and number of spectators, because it seems to me that price should be the independent variable, In other words, you set the price and that kind of determines the number of spectators. It may not be exact, but if you raise the price, you're going to lower the number of spectators and vice versa. So it seems to me that price is the independent variable and the spectators would be the dependent variable. All right, it depends. Number of spectators depends on price. Okay, so we have 2 points. PS. I'm going to call them P1, S1 and fill in the details. P1, S1 equals 26,000. So they told us that when the price was $11, the average attendance was 26,000. Okay, so we'll call that P1, S1. And we also have P2, S2, or more correctly P sub 2, S sub 2, but I get tired of saying subs all the time. Alright, so you get what I mean. 9 and 31,000. Okay, so what can we do with this information? Well, we can get the equation for the line. Alright, so what about, where does the parabola fit in, you might wonder? Well, let's do first things first, alright? This we can do now, and we'll have more information. It's better than a blank sheet of paper, right? So we've got something here, we've got something going on, let's do it. Don't worry about the parabola just yet. That'll kind of come to us later. Alright, so just worry about what you can do now and do all you can do. And then start thinking more about it. So we're going to use the 2-point equation for a line. Remember that? Remember that one? 2-point equation for a line. Alright, so we're using y minus y1 equals m times x minus x1, and instead of m we're writing out the formula for m. So instead of x's and y's we've got p's and s's. So the x's will be replaced by p's and the y's will be replaced by s in the formula. So we've got s minus s1 equals, here's the slope, s2 minus s1 over p2 minus p1 times the quantity p minus p1. So filling in the details, we've got s minus 26,000 equals 31,000 minus 26,000 over 9 minus 11 times the quantity p minus 11. And so this, the right hand side equals 5,000 over negative 2. That's the slope, times p minus 11 in parentheses, and that's equal to negative 2,500 times the quantity p minus 11. Okay, and you can distribute that through, so that equals negative 2,500 p and then negative 2,500 times negative 11 is plus 27,500. Alright, so before I erase to get more room, let me add 26,000 to both sides, and then let me shift it over here. So we've got S is equal to negative 2500p plus 53,500. All right. Okay, so let me erase so I can get more room to finish this problem. So here we go. Okay, so we want to find the vertex of this function r equals ps. All right. So R, revenue, equals P times S, which we already found out to be negative 2500p plus 53,500. Now here's our parabola. There you go. All right, so that equals, distributing the p through, negative 2500 p squared plus 53,500 p. All right. So negative b over 2a, I'll just use the formula for the vertex. Negative b over 2a is equal to negative 53,500 over 2 times negative 2,500. And that's 10.7. All right. So what's R of 10.7? That's the revenue, so you're getting $286,225. Now this is a parabola, again, that remember that opens downward because that negative leading coefficient. So this is a maximum. So that's the max revenue, and the ticket price for that max revenue is $10.70. That's your 10.7. All right. So there you go. Now, don't touch that dial because we've still got 2 bonus features left to go. Don't go away. Come on back. All right. Okay, bonus feature A. What we're going to discuss is how to derive the quadratic formula from the general quadratic equation ax squared plus bx plus c equals 0, where a is not equal to 0. Okay? So we're going to do it by completing the square. Completing the square works for any quadratic equation, so we can use it here. Now, if a is less than 0, if a is negative, in other words, we're going to multiply both sides of this by a -1. Multiply both sides by -1. And that means then a will be greater than 0. Now, you don't really have to do this step. You can do it without, you can derive the quadratic formula without doing that step, but it makes what I'm going to write a lot easier to follow. Alright, so it's a good idea for this little lesson. Okay, so let's do that. If a is less than 0, if it's negative, then multiply both sides by -1. Okay, so the right hand side will still be 0. -1 times 0 is still 0. So let's just assume that a is now greater than 0. Okay, so we have ax squared plus bx plus c equals 0. You might say, well, shouldn't it be minus, minus, minus? Okay, yeah, you could say that, but call minus a, call minus b, b, and minus c, c, alright? So we're not going to worry too much about that. Alright, so I'm going to subtract c from both sides. We've got ax squared plus bx equals -c. Alright, and then I'm going to complete the square on the left side of this equation. So you factor out the a, and you do that by multiplying both sides, or we don't have to actually factor out the a, we can just get rid of the a, make it equal to 1 actually, not get rid of it, but make it equal to 1 if we multiply it by 1 over a. And even if it's already 1, it'll still be 1 after we do this step, so it doesn't matter. So we're going to multiply both sides by 1 over a. So we're not getting rid of it, we're just changing it a little bit. We're just multiplying both sides by 1 over a. Times -c, and that'll give us a leading coefficient equal to 1, which makes things a lot nicer. Alright, so you distribute that through. On the left side, you're going to get x squared plus b over a x equals -c over a. Now, we don't have to worry about a in the denominator dividing by 0, right? What if a was 0? Well, a is not 0. It has to be non-zero in order for that to be a quadratic. Alright, so we don't have to worry about that being in the denominator. Okay? So we're not dividing by 0 here. That would not work very well. Now you're going to complete the square on this, and that's equal to, so let's take 1/2 of b over a, half the coefficient of x, remember that? Half the coefficient of x, and square that. So that equals b over 4a squared, or rather b over 2a, and then we're going to square that, so we get b squared over 4a squared. And we're going to add that to both sides. Now, you remember we did adding and subtracting. Well, that's the same as adding it to both sides, alright? So what we have then is x squared plus b over a x plus b squared over 4a squared equals -c over a plus b squared over 4a squared. Again, if you want, you can subtract that from both sides, and then you'll be adding and subtracting on the left side. Alright? So it's basically what we've been doing all along. Alright? So this on the left is our perfect square trinomial, and that equals x plus, now the second entry you would put here would be either half of that, that's 1/2 times b over a, which is b over 2a, or the square root of that, that's again b over 2a. And that's squared. Alright. And then over here, we've got negative c over a, and we're going, what we want is a common denominator, which is 4a squared. Alright. So we're going to do that by, or getting the common denominator by multiplying that by 4a. So you multiply by 1, but make it 4a over 4a. So when you multiply these two, you're going to get the common denominator 4a squared, and then we can combine the two fractions. Okay, so focusing on the right side, we're essentially done on the left. Not quite, but almost. Multiply these two, you're going to get negative 4ac over 4a squared plus b squared over 4a squared. And that equals b squared minus, if you combine these two, add these two, I'm going to put the b squared first. B squared minus 4ac on top over 4a squared. This is starting to look like the quadratic formula. So now you take the square root of both sides of this equation. Alright? Now since a is greater than 0, let me write this over here. Go over here. Then the square root of 4a squared is equal to 2a. Alright? So otherwise it would equal 2 times the absolute value of a. So that kind of would make things messier. So anyway, we take the square root of both sides, and now I'm going to have to erase to get a little more room. Okay, so when we take the square root of both sides, we're going to get x plus b over 2a equals plus or minus. So remember, when you take square root of something, there's a positive and a negative square root. Take the square root of 9, you get plus 3 and also negative 3, because negative 3 times negative 3 equals 9. So plus, that's where the plus minus comes from. And then you've got the square root of b squared minus 4ac all over 2a. Alright. Now we're going to add, or rather subtract that from both sides, the b over 2a. So you're going to solve for x, in other words. You get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And they already have common denominators, so combining the numerators you get negative b plus or minus the square root of b squared minus 4ac all over 2a. And there's your quadratic formula. Okay. Alright, so you might be wondering if there are formulas for cubic equations or quartic equation. What's a cubic? It's a degree 3 polynomial or degree 3 polynomial function. This is degree 2. That's degree 2. So there's, of course, a formula for that. We just saw that. There is a formula for degree 3, a general formula that'll work on all degree 3 equations, polynomial equations, and one for a degree 4. All right, quartics. If you ever have a lot of time to kill and you are interested in this stuff, try to use the formulas for the cubic, and then you might not want to do the quartic. I mean, using the formulas is extremely time consuming. All right, trust me, I've done both. And the quartic is much worse than the cubic, and the cubic is much worse than using this. All right, so what about degree 5, quintics or higher? Well, they've been trying to get formulas, general formulas for those for centuries, and nobody could come up with anything. And finally, in the 1700s, a mathematician named Galois, I'll spell his name, you can look him up. He has an interesting story, Galois. Évariste Galois, he was a Frenchman. He proved that there is no general formula for a quintic, degree 5. And he had an interesting life. He died as a young man in a sword fight over a girl. So his math was much better than his sword fighting skills, unfortunately. All right, so yeah, he passed away early, but before he died, fortunately, he gave us this great theorem. And a mathematician named Abel, Norwegian, spelled A-B-E-L, Abel. We get the name for abelian groups from him. You don't know what an abelian group is, probably, but that's something you study in more advanced mathematics. But anyway, Abel proved it for degree 5 and above. Anything degree 5 or above does not have a general formula like this. All right. So how do you solve those? Well, you use approximation techniques, basically, and you can use computers. And with the methods we have today and the computers that we have, you can solve for x to any degree of accuracy you wish, provided you have enough computing time and power. All right, so the more accurate you want your answer, the more time it's going to take and the more computing power you need. Okay, so but for all intents and purposes, we can solve them as well as we want to, and especially with today's computers. All right, but there are techniques, more than one, and to solve these degree 5 and above equations. All right, so but if you have degree 4 or below, you can use a formula like this and you'll get the exact answer. And for the cubic, for example, the exact answer is mind-bogglingly long. And nobody would really want to use that because it's just, when you write it down, it just takes up the whole paper. But it's an exact answer. So you'd rather have an approximation for practical uses anyway, right? But yeah, you can get the exact answer for degree 3 and 4 equations, polynomial equations like that. All right, so but that's as far as you can go, degree 4. So there you go. That's how you get the quadratic formula. Okay, bonus B. We're going to show how to find the coordinates of the vertex of a quadratic function which has the shape of a parabola directly from the equation of the function f of x equals ax squared plus bx plus c, where a is not equal to 0. That's the formula that you've been using all along that the book showed you, negative b over 2a, f of negative b over 2a. How did they get that? You may be wondering. All right. So we're going to show you how they got that. So they didn't tell you how they got that. They just threw it at you, right? So we're going to find out. So the x-coordinates of the vertex, the x-coordinate of the vertex, the x-coordinate singular of the vertex is halfway between the two roots of the function. Okay? So here's your two roots there, and the vertex is halfway, the x-coordinate of the vertex is halfway between the two roots. Okay? So another way of putting that is it's the average of the two roots, or the mean. Remember the mean? That's the average, the usual average we think of. It's the average of the two roots. Okay? So by the quadratic formula, one root is negative b minus the square root of b squared minus 4ac all over 2a. Okay? The other is minus b plus the square root of b squared minus 4ac all over 2a. Right? Because x equals negative b plus or minus. So that gives you the two roots, plus or minus, right in front of the radical sign there. Okay? So what we'll do is we'll take the average of these two roots. How do you do that? You add these two and divide by 2, right? There's two numbers. Take the average of the two numbers, you add them, and you divide by the 2. Okay, so that's, take the average. We've got negative b minus square root of b squared minus 4ac all over 2a. Add to that minus b plus square root of b squared minus 4ac all over 2a, and you might start to think that this is going to be pretty nasty, but don't worry, it simplifies very nicely. And they have common denominators on top here, so we'll combine them. Negative b minus square root of b squared minus 4ac minus b, that comes from that, plus square root of b squared minus 4ac. And that's all over the common denominator of 2a. And then all of that is over 2. Alright. So when you add like terms, negative 2b and then the radicals go away, don't they? Minus and plus, they're gone. Isn't that nice? So you get negative 2b over 2a. That's this whole top part, and then down below you've got a 2. That's the same as 2 over 1, by the way. So when you divide a fraction by another fraction, you invert the bottom fraction and multiply by the top. Negative 2b over 2a times, invert the 2 over 1, that becomes 1/2. Okay? And then the 2's cancel here. They could also cancel that way too. but you can only do one at a time, right? So you can't go both, cancel them, right? I mean, you can't cancel this and this out at the same time. All right, so that's equal to negative b times 1, which is negative b over 2a. That's the average of these two roots. All right. That's the x-coordinate. Remember, x equals the x-coordinate of that vertex. All right. And that was what they told you to do. To find the vertex, the x-coordinate is negative b over 2a. What's the y-coordinate? The y-coordinate will be f of that. All right. So that's where you get the nice little formula to find the vertex. Well, that takes care of this section. Wow, a long haul. I hope you can take a break because you deserve it. Pat yourself on the back and job well done. Congratulations. So we're going to continue on, right? But first, time for refreshment. So kick back for a little while if you can and take it easy. Take life easy for a while, all right? So we'll see you later.